Hello and welcome to this episode of Microchips, and today we're having a look at this customer's Superstar 360 FM that's been sent to me for work to try and get it back to its former glory. So before we start, don't forget to like, share, subscribe, comment, join the Facebook group, have a look at my website, all those good things. And let's get started on this vintage radio. So it looks like it's had a bit of a hard life, but nothing a bit of TLC won't sort out. So we're just having a look at the copper side of the printed circuit board, and immediately I can see a yellow wire going onto the 5kc pin of the PLL. Some old frequency expansion. Let's have a look at the component side, and immediately we're greeted with this. So I'm just powering it on, have a look what this is. So immediately the volume control's dirty, and the squelch is spinning round as well. So that's going to have to be sorted out. As you can see, the squelch doesn't have an end stop anymore. But we've got new ones of those, so we'll fit a new one in. Let's have a look at the frequencies. So there's the bands as you would expect, low, mid, high, which is fine, but then you flick the 5kc and it drops it down to other frequencies that probably don't correspond to anything, but I suppose in a day it was fine. It's better than a rat's nest of diodes on the underside, but never mind. But apart from that, it's kind of looking okay at the moment. Now this looks like it's some form of speech add-on. Not sure whether it's a compressor or just something to clean up the audio or make it a bit louder, or who knows. But it's definitely old, and it's definitely playing up, and it's definitely not working. Not sure whether the switch at the front's dirty or whether we've just got problems. You can hear we're buzzing. We've got buzzing noises, so it's definitely in the audio line. But I think this needs to come out. And it's making some really strange noises, so it's not happy. It's not happy, so I think we're going to have to remove it. It definitely sounds poorly anyway. So it looks like there's a loose connection somewhere on that, or who knows, but we're going to remove it anyway, because it's not good. So it's connected to a switch at the front, and it looks like it's drifting off to the mic gain, so that should be audio on the brown wire. I think our grey wire is the audio from the mic socket, and then we've got power switching to it maybe. But we can take all that out. Let's have a look at this. This definitely looks homemade. Somebody must have spent a while laying this out and drilling it, and probably had a small bath of ferric chloride acid to eat away the copper. You know, before the days of manufactured boards. Nice BC 109s on the transistors. So yeah, nice board, but unfortunately it's not staying. Nice little bit of vintage homebrew electronics there. I think I'll probably keep the BC 109s if they are good. You never know when they might come in handy. So let's just have a look at the audio. Yeah, connecting the brown to the grey, we get audio, so we know that's the audio path. And notice, as always, our meter is stuck, so that's going to have to be attended to. So I've already fitted one of my boards into it. Don't need to go over the fitting of that. Done that in plenty of other videos. So we're going to have 5 bands, 10kc, 5kc on it, and UK40. But for this to work, we need to lock the radio onto mid-band, because we don't want any false codes from those binary adders. So we'll just connect the purple wire to that point, and that locks MX2 to mid-band, and we can safely then pull the band switch out. So the black and yellow is the SFT wire, so we just ground those together, that's fine. And there's our switches. So that's the 3-position switch. We're going to repurpose that back into a 5-position switch. It's easy enough, I've got videos covering that. So there's our switches fitted, 10kc, 5kc fitted. The customer wanted the Roger bleep removing off channel 9, so that's been disabled. So we've got 10kc, 5kc, a reinstated tone. Let's have a look at this meter. So as always with these meters, nice precise flat screwdriver, just cut through the tape at the top. We just need to slacken this top screw off just a little bit, and that sorts the meter out. So you see, just turn it and boom, done. Very nice. So I'm keying up there, I didn't realise I had it in SWR mode, so we'll put it back onto RF mode, and yeah, we're working. Meter's happy. Yep. Okay, easy fix with that. Don't need to play with that anymore. We'll just give it a little bit more of a it's fine. Don't want to go too far, but I don't want it sticking again. Yep, that's fine. Beautiful. Yep, very good. So there's our UK40 offset, transistor, a multi-turn pot, and that's coming off the band select in the UK40 position. So here's the volume control with its rotating squelch control. I think I know what's wrong with that. I think it's been pulled too hard and it's not hitting its end stop. But we're going to fit a new one in anyway, because the old one was very noisy. Maybe we can repair the old one, who knows. But there's our new one fitted. Very nice. Okay, onto the alignment. So first alignment point onto TP4, just set the scope for maximum. So now we need to adjust our offsets. So we want channel 19 mid-band, and on AM we are looking for 16490, and that's adjusting L21. So using a ceramic trimmer as always, get it onto 16490. Okay, that's pretty close. Just make sure the KC shift is in the centre. We will go back over this a couple of times once we've adjusted other things, just to make sure everything stays within tolerance. So the next one we need to switch to USB, and we're looking for 16495. This one's adjusting L22. So we'll bring this up to 4925, and I'm actually going too far with that one. So we'll bring it down. There's our 4925. One of these adjustments is really sensitive and another one is really easy to do. You just got to be patient. Tiny little turns. 164925, pretty close. Now for LSB we're after 164875 and we're adjusting L23. And we're on TP3 as well. 164875. Very nice. Now to make sure that the TX and the RX is the same, we need to adjust VR6, but we need to go into LSB transmit mode. As you can see, as we key up, the transmitted frequency changes. So I've turned the AM power down as well so we don't get any interruptions from the RF stage. So what we need to do is we need to match this with the received frequency by adjusting VR6. So this will ensure that our transmit and receive are aligned together. So 4875 again, it's close. These pots are a bit dirty as well. Okay, there's 4875, pretty close. So we're just going to go over the adjustments on L21, 22 and 23 again, just in case they've moved. So we're just verifying that was 4875. This one should be 4925. Yeah, very nice. The last one back onto AM 4900. Okay, everything's pretty close. Don't think we'll ever get it absolutely bang on, but it's as close as. It's good enough. Just a few hertz out, so it's good. Just recheck VR6 because we've readjusted the offset again. I think we're pretty close. So there's the difference between transmit and receive. Yeah, it's all good. Very nice. Let's have a look at our 10692. So we're on TP6 and we need to be setting for 10692.5 by adjusting L38. And once we've done this, we need to adjust L39. Go into LSB. So we're adjusting for 106.975 on our L39. So a few turns on that one, and there we go, 6975, excellent. Now to adjust the AM 695, we need to go into AM transmit and adjust L37 for 271850. There we go. So that's our 10695 aligned. So let's have a look at the power output. So I've adjusted the AM power back up again, and it seems to be healthy down the bottom end of the band, but as we move to the top end of the band it drops out a little bit. So what we'll do is we'll just have a quick go over of the pre-cans, just make sure they're just peaked up, and then we'll adjust this one, and that one makes the big difference. So we're just going to check it across the bands, make sure it's level-ish, which it seems to be. Okay, that's good. Now to adjust the bias of the final and the pre-drive. So from previous experience on these, I know that the pots are a bit dirty, can be a bit twitchy, so I'll give them a spray up first. We've taken out the board. Now we'll connect our ammeter between the two test points, between TP9 and TP8. I'm going to select USB with no mic gain at minimum, and we need to adjust this first one for 50 milliamps. So adjusting it nice and carefully. There's our 50 milliamps. So we need to readjust the R11 now. So we'll move the test point to TP8 and no, sorry, we need to move it from TP8 to TP7. And this one seems to be very high, which got me a bit concerned. I just had to turn it down, and we could finally get the 50 milliamps as per the service manual. Little bit of back and forth adjustment, and it gets it roughly about there. Let's go and check the driver first. Check the driver again. Make sure that's 50 milliamps. Check the final again. Make sure we've got 50 milliamps there. It's going to be as close as. That'll do. Don't want it up too high and feed the base with too much. Don't want to damage our final transistor. I did have a look on the two-tone as well, and everything looked nice on the two-tone, so there was no problems. So let's have a look at our frequencies. So low, mid, high, and there's our UK40, and you can see our UK40 is off. So we'll turn the radio over, adjust our multi-turn pot, and bring down the frequency to 60125. So we've got it on 6012. Adjust the gate time on the scope, on the frequency counter, just to give that extra digit of accuracy. And there's our 60125. Very nice. Now let's have a look at the RF front end. So I've adjusted the meter preliminary. So we've got minus 70 dB, so just over S9. Of course they're dirty, so I'm just giving them a clean. Giving them a squirt and a quick adjustment, so we're just over S9 for minus 70 dBm. And we'll have a look at the front end and see how see what our sensitivity is. So I've dropped the RF input, and I'm just going to drop it to a point where I can just about see the needle moving. So we'll set it about there. That's about minus 90, minus 100 dBm, and then we're going to put this core all the way to the bottom, and we're going to adjust the RF output to give us a little bit of movement on the needle, and then we're going to peak the coils up. So I'm just going to adjust that one just to give me a little bit of a reading, and then we're just going to go over the other three just to peak them up. Once we peak them up, we bring this one back up again. This brings it back. Very nice. So RF front end seems good. Let's have a look at this cyanide stuff that everybody keeps going on about. So looks like it's around 12 dB cyanide, but if we just adjust the KC shift just a little bit, that gets it down a little bit. Like I always say, if you can hear the tone at minus 110 dB going into minus 120 dB, you're fine. Don't need to be recording all dB numbers against cyanide numbers on a piece of paper. So what we'll do is we'll just have a look across the bands. So go to high band, have a look there. Seems good. So channel 40, UK 40. So we need to spread it out a bit. So what I'll do is I'll just go in and just adjust one of the coils a bit just to bring it up. But it's going to take a little bit of work just to level this out a little bit. So we'll go to channel 1 twice low, 26065. And we've got nothing there, so we need to just bring it up. So what I need to do is we just need to get a happy medium between the lowest channel and the highest channel. But what I always try and do is I always try and give it a bit more, try and lean it towards the top end, because nothing ever happens on twice low anyway. Well, so there's no point putting tons of gain down that end when you need it up on high band and UK 40. So it takes a little bit of work, a little bit of going to and from frequencies just to get it right, should we say. So if we go back down onto the lowest frequency again and have a look at that, You see, you never get it peaked in the right place, so we just have to spread it out best we can. What we can do as well is we can change the meter diode to a Schottky diode to make the meter a bit more responsive as well, which we'll do later on. But we're still getting S9 for minus 70 dB, so that's good as. We'll bring it down. Yep, it's fine. I think our sensitivity is good enough. So whilst I'm in here, I'm just going to change these two 10-volt caps in the AGC because they have caused problems in the past. So it'd be silly not to change them whilst we're in there. So we'll pop in a couple of new 47 mics. There we go. And we'll get those soldered into place. Very nice. So let's have a look at this display window. So it's a bit scratched up, a bit dirty, so giving it a clean. Still got some scratches on it, so I'm going to try a little bit of polywatch on it. Let's see if that removes any of the scratches, or makes them a bit better, should we say. I'm not going to remove all the scratches without rubbing it down with some 1500 or 2000 paper. But I'm not going to do that. I'm just going to give it a quick polish over with some polywatch. And see if we can get it a little bit more shiny instead of it looking dull like it did do. And sure enough, polywatch has brought it up. It's not brought out the deep scratches. It's got rid of those surface scratches. So yeah, job's a good one. Happy with that. It's a bit shinier. Very nice. So the customer wanted me to fit a decal because the front was a bit tired. So for fitting a decal, we need to rub the old one down. Now getting this decal off was an absolute pain. I don't know what they glued it down with, but it wasn't the normal weak glue. So we rubbed it down as best we can. It's not perfect, but it'll do. So we're just rubbing over with a bit of alcohol just to degrease it. Everything looks fine. So I completely forgot to turn on the recording whilst I was fitting this. But I've done videos on this before where you spray the surface, offer up the decal to it, and then we pick it back up again as I'm rubbing out all the liquid that I've used. So just rubbing out the excess liquid. And then what we'll do is we'll put it under something flat to press it down for 15 minutes or so. As I tried lifting it there, it lifted back up again. So obviously the adhesive hasn't worked its magic yet. So we put it under something nice and flat. And it's looking good. Nice custom decal. So I've used some 3M tissue tape, double-sided tape on the back. We cleaned the front up, so there's no old adhesive left. We're taking all the backing off the tissue tape. This should hold it down nicely. So we'll offer it up to the front of the radio. Make sure we're in the right place, and then give it a good push down. That tissue tape is going to stick it down. There we go. Excellent. So, don't look too bad at all. Looking a little bit more respectable. So we've reassembled the radio, and we're just giving it a test. As you can see, we've got our 10kc, 5kc, our 5 bands, and a nice decal fitted. I think the customer should be quite happy with this. So anyway, that's our Superstar 360 FM done. Bit of a long video this one, but somebody did mention they like to see Uniden alignments, so maybe we can do some more of that. But anyway, thanks for watching. Don't forget to like, share, subscribe, comment, join the Facebook group, buy me a coffee, join Patreon, have a look at the website and all that. Thanks for watching, and we'll see you in the next episode.